In this video, I'm going to go over how to perform the ratio of specific heats experiment using our PASCO products. So to start, you're going to need an 850 or 550 universal interface, either or will do. Next, you're going to need the heat engine apparatus, and this guy is mounted to a large A base and then a stainless steel rod, at least 45 centimeters. Doesn't need to be any longer than that, but as long as you have one at least that length, you'll be fine. The next we have a dual pressure sensor right here, and then we have some tubing to connect. So to start this off, we're going to connect one end of the open tube to the heat engine, lock it in. And you'll see there's a little red valve on here. Make sure this is open right now in the parallel with the length of the stem. And then we're going to connect the other end to port 1, this guy right here. Get it in there. There we go. Then we're going to connect this to the 850 here. All right. So to start this off, we're going to raise the piston up to the 70 millimeter mark. Once we have it set, we're going to tighten this thumb screw right here. Going to tighten this, and this will hold the piston in place. So at this point, take the valve and we're going to close it. All right. So next thing we're going to do here is we're going to open up capstone. And so when you open up the experiment file that comes with this experiment, this is what it's going to look like. I'm just going to gloss over these and we're going to get right into the data collection. So to start off, we're just going to go straight to the procedure page. If you read the steps on there, that's what I set up right here already. So now we can go ahead and loosen this thumb screw here. And the piston will stay in its current position because the valve down here is closed. So this is where the tricky part is getting good data. And this requires a lot of patience in order to do this. So I'm going to do several runs here, and one of these will eventually produce a good one. So to start here, we're going to hit record, and then we're just going to tap the plunger head there. And then we're going to go ahead and expand this out. And so you see from here, we're trying to look at how this piston oscillates inside the air column here. Ideally, you want at least 4 peaks. Here we only have about 3 good ones. So we're going to keep on trying until we get a good one. One of the real tricks here is to hit it as dead center as you can. Oh, not a good one. Try again. Let's take a look at this one. Yeah, once again, nope. Record again. Once again, still not ideal. We want at least 4 good peaks. Again. Keep on trying. And if you hit it just right, there we go. There we go. So we'll zoom out here and we'll expand this out so you can clearly see the peaks. So you see we have 1, 2, 3, 4 good peaks at least here. So now we'll go over to the analysis page. I like this graph better because it'll display the entirety. See, let's keep expanding this out. There we go. And then we'll zoom out a little bit. All right. So now for this next step, what we need to do is find the period of these oscillations. So we are going to measure from the highest point. We're gonna just click on the highest point, the peak, and we'll add a coordinate. Then we'll go to the next peak. Zoom out here. Then we'll add another coordinate. And then from here, with the delta tool, and this will give us one period. So that's the first period. Now we need to find the second. So we'll just drag that coordinate tool down here, and let's just zoom in to make sure we did in fact get there we go. This one's 40. So I'm just going to keep track in the table over here. So we have 55. Well, I'll do it in this 55 and then 40. And then we'll find the next peak, which will be somewhere in here. And we have a delta T of about 36 there. So what we'll do now just by hand here. Open up the calculator. And we're going to take an average of these three numbers. So 55 plus 40 plus 36. And then we'll divide that by 3. This will be our average period for the 7 centimeter mark. And we'll record that value right here, 43.67. 67. And then we'll just go ahead and delete these. All right. You'll notice you have to do this at least 4 more times. So just repeat the same set of steps for each of these piston positions. So then we'll go down and we'll move this to the next position. So we'll open the valve here. Piston drops. And then we'll bring it to the 60 millimeter mark and clamp it. And close the valve again. And then we can release the thumb screw. And then do the same data collection process as we did just now. So for the next step, we're going to verify. You'll see if we will make a graph of all these data points. So let me open up another piece of software that has data already inside. So we'll go ahead and close this. Guess we don't need the calculator anymore. It's taking its sweet time. There we go. So we'll go to analysis 2 here. And as you can see, once you've gone through and performed the previous steps at each mark on the piston, you should see a relatively linear relationship amongst those. And what you'll do is you'll take the slope of that line and apply it to this equation here. And after you calculate this out, for this particular set, we have we actually got a good value here. We're with 0.7% of the theoretical value. When you're on this page, you have to go through and fill out some of these fields. You have to fill out the mass of the piston. Keep in mind that this is in kilograms. Also note, this value may be different depending on the unit that you have. Let's see. If you look right here on the heat engine, you will find the specification for the mass of the piston written on here, as well as the diameter, which will vary depending on which unit you have or which model is being used. So once you populate these fields, you will be able to solve for this equation and verify the ratio of specific heat for air. As far as this lab goes, you can continue and use a different gas. If you have access to it, you can use helium. This is a whole other process I won't go over in this video, but the procedure is exactly the same. You're filling this column with helium instead of the air you're surrounded by. And that's all for this video. If you have any questions, reach out to me. I am bpruitt@pasco.com. Thank you.